Okay, Bismillah Rahman Rahim. Electromagnetic field theory. And in the previous session, we have studied the electric potential due to system of charges, electric potential due to line charges, and then due to surface charges, and then due to the volume charges. And after that, we have done some numerical example based on this theory. So now electric potential gradient. Potential gradient is defined mathematically as E is equal to divergence of E. Okay, so now for example, this is Q, this is point of observation B, and it is apart by a distance of R. So E will be q, as we know that E is equal to q divided by 4 pi epsilon naught r square, which we have already proved this relation in the previous lectures. And this is always along the radius, along the direction of r. Okay, so now absolute potential at the point of observation will be v is equal to q divided by 4 pi epsilon naught r. Now taking the divergence of this v in spherical coordinate system, as we know that uh, partial over partial r of v around ar plus partial v over partial theta along a theta plus partial v over partial phi along a phi. So as we can see that uh, the the e is along ar, so v will always be along ar. So these two, the a theta and a phi term will be always zero in the case of taking the divergence of v, because v is always directed towards the radius. So we will left with only r term. So taking the derivative of this term, q over 4 pi epsilon naught r. Okay, so 1 over r, the uh, rest of the terms are the constants. So 1 over r is the only variable. So 1 over the derivative of 1 over r will be minus 1 over r square, because okay, r raised to the power of 1 minus 1. So derivative of this will be r minus 1 minus 1. Okay, and minus as well this minus. Okay, and r raised to the power of minus 1. So we will get minus 1 over r square. So that is here, q minus q divided by 4 pi epsilon naught r square in the direction of ar. So as we can see that the only difference between the e and the del dot v is the minus sign. Okay, so e will be equal to minus rho v. Okay, this is actually the what this is actually the e. Okay, so or we can say that or we can say that e is equal to minus rho dot v. Okay, so this really equation is valid for all the coordinate system, not only for the spherical. It can be valid to the rectangular coordinate system and cylindrical coordinate system as well. Okay, now the electric dipole. So first of all, what is a dipole? In dielectric material, uh, we will study that all the dielectric material are formed of the dipoles. Some of are the permanent dipoles, and some of are the um, temporary dipoles. Okay, so what are actually dipoles are? Dipoles are the two oppositively charged particles having the same magnitude but having opposite directions apart by a small distance, for example d. So this is actually called the dipole. This is the dipole. And dipole, the name reveals that di means two, two oppositive charged particles placed at different poles. Okay, so one is at the south pole and other is at the north pole, for example. Okay, so this will be a dipole. Okay, so if we want to find the electric potential due to a dipole, so it means that we have to find the electric potential due to two source charges, because dipole is made up of two charges, not the single charge. So we will have two source charges, one is positive, the other is negative, and we have to find the electric potential at some point p because of this dipole. So let's let's find the electric potential at point P due to the dipole. I will draw this figure again separately for you to easily uh, get this figure. Okay, so let's suppose this is point of observation which is closer to plus q and a bit far from minus q. So okay, so this is actually the r1 position vector of plus q from point of observation p, and the position vector of point of observation from the minus q source will be, for example, r2. Okay, this is the this is actually the dipole, okay, having two slits. Now this is the midpoint. For example, this distance is r. Okay, so and the distance between these plus q and minus q will be d, which is very small. Okay, so I will draw a perpendicular line over here. Okay, so that I get a right angle triangle. This is a 90-degree. Okay, this is the angle theta. Okay, now at this point the r1 and r2 are equal. This is actually, this distance is from here to here, this is equal to r1. Okay, so how much distance it will be? This is actually r2 minus r1, means r2, this whole is r2 minus r1, this is r1, this is equal to r1. Okay, so this will be r2 minus r1. So according to this right angle triangle, this will be the perpendicular, this will be base, and this will be have a d will be hypotenuse. Okay. So now comes to our theory portion. Consider we have 2 point charges plus q and minus q. They are separated by a very small distance d. They have equal magnitude but opposite polarity. That is why they are called electric dipoles. Okay, let point of observation P is located very far from these charges. Let position vector of point of observation is R. R1 and R2 are the distance vectors between the point of observation and the charges plus Q and minus Q respectively. Okay, we have drawn these position vector here. Okay, so the electric potential due to the plus Q will be uh, symbolically represented by V plus, and for that of the minus q will be represented by V minus. Okay, so the electric potential of plus q charge will be given by q divided by 4 pi epsilon naught r1. Okay, and that of the minus q will be represented by minus q divided by 4 pi epsilon naught r2. Okay, this is the position vector of r q1 minus q, and this is position vector of the plus q. Okay, so as these two will be add up, because the superposition it obeys superposition theorem, so v net will be equal to plus v plus v minus. Okay, okay, so v plus is given by this relation and v minus is given by this relation. Taking q and 4 pi epsilon naught as common, so we will left with 1 over r1 minus 1 over r2. Taking the LCM, R1 R2 will be the LCM, so here we will get R2 minus R1. Okay, from the figure, okay, R2 minus 1 R1 is equal to d cos theta. How? Applying the cotangent cos theta on this right angle triangle, base or hypotenuse. Okay, so base is what R2 minus R1 is our base. Okay, and hypotenuse is d. Okay, so from here you can see that R2 minus R1 is equal to d cos theta. Okay, cross multiplication, d cos theta will be equal to R2 minus R1. So putting the values, R2 minus R1 is equal to d cos theta. Okay, as d is very small, so R1 will be equal to R2 will be equal to R, because the square of the small will be more small, so the chance of error will be less. So I can write R1 R2 as R square. Okay, so replacing the values, v is equal to q divided by 4 pi epsilon naught d cos theta over r square. Okay, okay, and it is along a unit vector az, so d will be equal to d az. Let ar be the unit vector in the direction of the position vector r, so d dot ar, the magnitude of d is d, the magnitude of ar unit vector is 1. Okay, that due to dot product we will apply cos theta, so d cos theta will be can be replaced by d dot ar. Okay, so replacing d d cos theta by dar. Okay, let p is the dipole moment, which is defined as p is equal to q into d. So replacing this is in order to get the v in term of the dipole moment, which will be useful in numericals. Okay, if you are given the value of the dipole moment, so you will apply this formula. Otherwise we have finished the v till this. Okay, so v is equal to p dot ar divided by 4 pi epsilon naught r square. That was the v. Now if you want to find the e, okay, so e is equal to, according to this relation, e is equal to minus divergence of e. Okay, so applying the divergence. Okay, so putting the values of v from here, from here. Okay, v is equal to q over 4 pi epsilon naught d cos theta over r square. So putting the values of v over here and taking the divergence in spherical coordinate system. So for the ar, theta will be constant, and for the theta, r will be constant. So you will get this minus 2 cos theta over r cube minus sine theta over r cube. Okay, so this will be e after applying the divergence on the v equation. Okay, now if you want to find the dielectric dipole in RCS, so it is very easy. Just replace ar with r over r absolute. Okay, r is r2 minus r1, so ar will be r2 minus r1 divided by r2 minus r1 absolute. Replacing this ar over here, so you will get v is equal to p, this is the dipole moment, r2 minus r1 divided by 4 pi epsilon naught r2 minus r1 whole cube. Okay, the one is the square is because of this, and the one is due to this absolute, so we will get the cube for this relation. Okay, so we will discuss the numericals of based on these electric potential due to dipole and the dipole moment in the next class, inshallah. And we will then switch to magnetostatics, because and we have two portions in electromagnetic field theory. The one is the electrostatics and the one is the magnetostatics. So by this the electrostatics will be end up, and then we will start the magnetostatics for this portion. So that was all about the uh, electric dipole, electric potential to dipole, and potential gradient. Okay, so thank you for the moment.